So in this video, we will see how to manage infrastructure with Terraform and GitLab CI. Okay, so where we will have a repository with a Terraform configuration, and we'll write the GitLab CI pipeline. So that will deploy your infrastructure using Terraform. At the same time, once the infrastructure is deployed, so it will also install an application which is an HTTP server in all the nodes. Okay, so whatever EC2 instances, basically we will use EC2 instances. Okay, we'll create EC2 instances with Terraform. So once these instances are created, we will use Ansible to deploy some application, and also we'll try to access it. Okay, so this video is important because we are trying to cover a lot of things, like how to use GitLab variables inside your pipeline. So what are GitLab artifacts, cache, keywords, executors, and we'll integrate Ansible playbooks. Okay, and other thing is, instead of using local backend, we will also see how to use GitLab as the remote backend for our Terraform state file. So there are multiple things we will try to cover in this video. We'll start with GitLab overview, because directly diving into the whole pipeline will not make any sense unless you understand all the concepts in GitLab. Okay, so we'll talk about all those concepts. We'll start with GitLab overview, then we'll understand the overall pipeline that we are going to build using GitLab CI. Okay, and then how to configure infrastructure using Ansible, right? We'll also understand executors in GitLab, and how to use Docker executor for GitLab runner, GitLab variables, jobs and stages. Okay, so in this also we'll see a lot of things like how to define a manual job. Okay, and then how to disable jobs, a lot of things. And then we'll understand various keywords. These are very important keywords, such as image, needs, okay, dependencies. So a lot of keywords. So all these things we'll understand. And important thing we'll understand is cache and artifacts, why these are required. Okay, so instead of doing Terraform init, Terraform format, validate, and then apply, okay, in a single environment. Okay, so we call it as an executor environment. So we'll try to separate each of these things into different jobs. Okay, so in this case, if you do Terraform init in Terraform, basically it generates the .terraform folder with all the providers and modules output, right? If this Terraform folder is not available for the apply stage, okay, or the apply job, ideally it will fail. Okay, it will ask you to run Terraform init again. Correct. That's the reason why we need to share certain things between the jobs or between pipelines, for that matter, in case if we have to share something. So for that reason only, we'll understand the difference between cache, and then we'll the requirement for artifact, how to clear the runner caches. Okay, and we will see how to use GitLab as remote backend to store Terraform state. Okay, so there is a big configuration involved. Okay, so we will also see about that. And also how to store SSH keys in GitLab, because once our instances are provisioned through GitLab, so we'll use Ansible to configure those instances. So for this, Ansible requires a private key to connect to the remote instances. So we'll see how to store SSH keys in GitLab, because by default GitLab doesn't offer any other method of storing SSH keys other than using variables. So we'll understand how to securely load our SSH keys into our job. Okay, and finally we'll understand the use of this GitLab workflow VS Code plugin, so which I find it very interesting. Okay, so instead of going into GitLab UI to see the jobs or the stays related output, like the console output, directly we can see it in the VS Code itself. Okay, so for this we need to have VS Code installed. Clear?
Yeah.
Okay, so this is the end-to-end CI pipeline that we are going to see. So we'll be using a lot of tools. Okay, so we have Terraform, we have Ansible. Okay, and of course we have GitLab. So what we'll do is we'll create a repository in GitLab, and then from our local machine, so we'll push all our Terraform configurations, okay, into our GitLab repository. And also GitLab requires this .gitlab-ci.yaml file. So this is just like the Jenkins file. Okay. So the GitLab, CI, basically will detect the presence of this file and automatically it will run that pipeline. Okay. So we'll also see how to create this particular pipeline file and then push it to GitLab repository. Okay. We all know that, if you have to work with Terraform, you need to have Terraform configurations and providers, etc. And we have whole Terraform workflow. Like we will start with Terraform FMT to format our code, and then we do Terraform init to download the providers and modules, and then we will validate, right? Because validate has to be done only after having the providers and the modules downloaded. Otherwise, validate command will simply fail. Terraform validate command will simply fail. And then we have apply, and then we have destroy. So this is the overall workflow. Okay, so I will not run all these commands in a single job. Instead, what I'll do is I'll create a separate job for each of these steps. Okay, so like for FMT, I'll create a job. Okay, for init, I'll create a job. Okay. Okay, before that, once you have this GitLab-ci.yaml file, so what GitLab will do is GitLab has to run that pipeline, right? So where exactly it will run? Okay. So we already seen in case of Jenkins, right? How to use Kubernetes pods as Jenkins agents, where a pod will serve as an agent, right? Our environment. Correct. So our
Yes.
entire pipeline runs here. Similarly, if you are using GitLab, SaaS platform. Okay. So their own platform. Okay. So you have either, you have an option of creating your own runner. It can be local runner, or it can be an EC2 instance or EKS cluster in anything, or else they'll provide a shared runner where this runner will be shared across multiple projects and multiple pipelines. Okay. So they'll create the shared runner, and within the shared runner, you can run your jobs. Okay. So there are various ways you can run your job. Either you can run it in a default image, which is based on Ruby, that that will be used as an executor means, again, within the shared runner, some environments will be created. Okay, so you have a shell executor. We will see it again in the theoretical part. We have Docker executor, Kubernetes pods as executor. In our last GitLab end-to-end video, okay, so we had seen how to use Kubernetes pods as executor. But here, what I will do is I'll use Docker containers as executors. Okay, so where, for running the Terraform FNT, what I will do is I'll create an image. I mean, already there is an image from HashiCorp that has Terraform CLI installed. So we will run that container, and inside that we will use FMT. Okay, similarly, we'll use init in a different job. Got it. And finally, so what we will do is within another container, we'll apply the configuration. Got it? Understood.
Yeah.
And after that apply, we will use another container that is that will have Ansible playbook binary. Okay, so it will actually configure the instances. So we have one container that does the apply, another one it will configure our instances, and we'll have another job that is the destroy job. But destroy job, I will not automatically run it, but I'll make it as manual job, where only when I manually ask it to run, then only destroy job will run. Okay. So there is another component involved. If you see, there is this cache that is shared across various jobs. Why this is required is, okay, so if you do Terraform init in one of the container, okay, it will generate the .terraform folder that has all the providers and modules information, right? Okay, so if that data is not shared across various jobs that require that folder, your simply your jobs will fail, because by default jobs are not connected through a single shared environment. Okay, but in case if you see Kubernetes pods as build agents in case of Jenkins, okay, so all the containers share a common
MTTR.
MTAR location. Okay, so which means they can share the data, but here they cannot share the data until and unless you use cache for whatever jobs you require. Okay, so you can turn off the cache. Again, I'm going to show you how to turn off the cache in the theoretical and practical part as well. Okay, and one important thing is we can now store the state file inside GitLab backend only. Okay, so instead of using S3 bucket to store the state file and DynamoDB for the state locking, we can do the same thing inside the GitLab directly. Okay, that is one thing we are going to do. And another thing we are going to learn is how to use SSH keys, okay, for our Ansible playbooks. That also I'm going to show. Okay, so this is the end to end. So first thing is you will push the source code, and then second step is the GitLab. Once it finds this GitLab CI, it will create a shared runner. Okay, and then all the jobs will execute. The first job is init job, that is going to download the Terraform provider and modules information, and then the cache is shared across all the jobs. Like we'll do init in one, validate in one, apply in one, configure in one, and then destroying one of the jobs. Okay, so they will ideally go and create the infrastructure in the AWS for us. Okay.
Yeah.
Now, before understanding the pipeline, let's understand all the important things to know about GitLab. So GitLab is an open source collaboration platform, okay, that has very powerful features behind beyond acting like a source code management tool. Okay, so it is not the only it is not just the SCM tool. It has a lot of other features as well. Okay, so just like GitHub, you can track issues. Okay, you can also host your packages. Okay, you can create registries to store the container images, maintain wiki, and also it serves like a continuous integration and deployment tool. Okay, we also have GitHub Actions for GitLab, right? Similarly, for GitLab, it is GitLab CI. Okay. So we have a lot of versions like free, premium, ultimate. Okay, so of course you can host your public repositories without any charge. But if you have to use GitLab CI, okay, so you can use up to 400 CI/CD minutes per month. Okay, and up to 5 GB of storage. So this is for the free account. Okay, but for the enterprise and all, you can reach the support. And signing up for the GitLab is very easy. You just have to go to gitlab.com. You will have a form. So instead of creating a separate account, what you can do is you can simply use SSO. Like you can sign in with GitHub or your Google existing accounts. Okay, and what is basically a pipeline? So it is a series of steps that we perform to deliver a new version of the application, right? So we start with build, test, and deploy. Of course, there are some intermediate stages which we are not considering. Okay, so it start from build. So where GitLab can talk to source code management tools like GitHub or its own GitLab. And then for build and automation, test automation, you can use GitLab CI, Jenkins. Okay, and for the build tool, you can use Maven and then Selenium. Like, okay, Docker, you can build the Docker images out of your build. And then you need to push your artifact, like whatever it is. It can be ZAR file, WAR file, container image. Okay, it can be any artifact like PDF file, log file. Okay, you can store it in Nexus, JFrog, or you can push it to Docker Hub. And then finally, you can deploy it to various environments like GCP, AWS, Azure. Okay, so this is complete end-to-end pipeline. And now coming to GitLab CI/CD tool. Okay, so just like if a repository has Jenkins file with capital J. Okay, so this is a standard file for the your Jenkins pipeline, right? The name is called Jenkins file. If you have a repository with Jenkins file, automatically Jenkins can detect and run that pipeline, right? So what is this Jenkins file? It is just a pipeline. So it will have series of stages and various steps inside that particular stage. Okay. Similarly, how GitLab detects the presence of pipeline file is with .gitlab ci.yaml file. So if you have this file, automatically GitLab will run that particular pipeline for you until you disable that auto DevOps part. Okay, by default it is enabled. Okay, anyways you'll have 400 minutes per month, right? So you can easily use it. Okay, so this is the file, and now this is the sample GitLab CI/CD pipeline. Okay, so it is entirely different from your Jenkins file. Okay, so here you'll define the stages, and then you'll have the individual jobs. Okay, so all these are individual jobs, and then you can decide to which stage a particular job belongs to. Okay, using the stage keyword. Okay, if you see this build job, okay, it belongs to the stage build. Okay, and this is a list you can see here. So which means the elements are ordered, correct? Okay, so all these stages run sequential. Okay.
Yeah.
So one stage after the other. But if a build job has 10 different jobs, all these jobs will run in parallel. Okay. But stages run sequential.
Sequential.
Okay. And this is how your GitLab repository should look like. Okay. You should have .gitlab -ci.yml file in case if you want to enable your DevOps. Okay. DevOps pipeline. This is GitLab workflow, VS Code plugin. So this is a very good plugin. Okay. And once you install this plugin, right, sometimes you will also be asked to download this YAML plugin from Red Hat. So it will show as a suggestion. So it's better to install that as well. Okay. Otherwise, it's not required. Okay. If you already have. Okay. Now let's talk about runners and executors. So what are runners and executors? Okay, so these are just like agents in Jenkins. So instead of running your pipeline inside your own, the master server, so we'll create separate environment for our pipeline, right? So this is called as a runner. Okay, so runner is simply an application. Okay, you can download that runner application and you can run it anywhere. Okay, in fact, you can run it as a Kubernetes pod. Okay, you can run it in an EC2 instance. Okay, so now that environment becomes a runner for it, runner for our main GitLab server. Okay, got it. So what is the main role of this runner? Okay, so it creates an environment for your build job. Okay, so it starts with downloading the entire project code. Okay, along with your GitLab -ci.yaml, and it will do it will run all the steps that are part of that pipeline. Okay, clear?
Okay. But here, Vikram, it's like agent in Jenkins, right? So we are using any Docker agent or Kubernetes agent, right?
Correct.
Jenkins. So
Yeah.
here also we can use the same thing, right?
Yeah, correct. Here,
Okay.
see, by default, this runner is an application. So if you deploy it in a simple VM, okay, that runner will be installed here. So it will run, all your particular code will run here. Okay. So let's say if you're, see, runner is different from executor, remember. So runner is just an environment. Okay. So if you take this runner, it is an application. So you can run that application anywhere. Okay. So when you try to, so let's say you can run it as a pod. Okay. So you select a Kubernetes cluster. Okay. And then inside that cluster, this runner will run as a pod. Got it. Now coming to the executor, let's say if each job requires a separate pod to run. Now what this runner will do, it will create another pod to run that job inside it. Okay.
Okay.
Got it. Let's say you have a job that requires to build a Docker container. Okay. Then what will be your runner? Runner can be anything. So here runner is an EC2 instance, let's say. So here you have the runner application running. Now, if your job requires container to be built, then inside this EC2 instance, you need to make sure that you have Docker installed. Got it.
Yeah.
Okay. Like that. Okay. And each job, okay. So whatever your GitLab CI runs, it runs in a workspace. So in Jenkins, we know it will have a workspace, right? That can be accessed using environment variable called workspace. Okay. So it will be under Jenkins home. Okay. Slash workspace. Okay. Slash your job name, right?
Yes.
Similarly, every job inside GitLab CI runs inside the same workspace, but here it is called project dir, which can be accessible using this environment variable. Okay. So here runners can have multiple executors like Docker, Shell, VirtualBox. It can be anything. Okay. So you can run your own runner inside your own laptop or inside some cloud, or else you can use shared runners that are provided by GitLab, but they have only free 400 minutes CI minutes. Okay. And runner can be anything. It can be simple SSH. It can be a shell. It can be VirtualBox, Docker, container, or Kubernetes pod, as already discussed. Okay. Got it. What is a simple shell executor? If you simply run shell commands, okay, so it is a shell executor. This is the simplest executor. Okay. right? Okay, if you see here, we have script, and then we have two shell commands. Okay, so docker build and docker push. Okay, so if you are using shell executor to build containers and all, we need to make sure that we have docker installed in the machine where runner is running. Okay, and also we can have docker executor, so where your build will run inside a docker container. And also we have Kubernetes executor, which we had seen in GitLab end-to-end pipeline. Okay, so that is Kubernetes executor, where it will create a new pod for every job. Okay, again, it depends upon how you configure the GitLab CI, right?
Okay.
Now coming
So
to
both
this,
runner and executor should be in the same machine, right?
yeah, that's correct.
Okay.
Okay. So stages and jobs, as we already know, you can have multiple stages and you know and multiple jobs. A job should belong to one of the stages. Okay, you can have multiple jobs per stage. All the stages will be executed sequentially, but jobs inside them will execute parallelly. Okay, so you can see stages. We have 3 stages, and these are all the individual jobs. Each job should belong to a particular stage. Okay. And here,
Okay.
let's say a build job has 5 different build stage has 5 different jobs. Okay, if any of the job fails, the whole pipeline aborts. Okay,
Okay.
that is one thing. And inside this job, whatever you wanted to do, you have to write it in the script block. Okay, so it can be a simple shell command, or it can be anything.
Okay.
Got it? And one more thing here is you can also control when a job should be executed. Okay, let's say I wanted to build a project, but I wanted to run that build job only when the event is a merge request event, or if the current branch is only master. Okay, so I can restrict jobs using those conditions. Okay, using clauses. Understood?
Okay.
And here, so GitLab defines 5 different stages. So one is pre, there's build, test, and deploy, and the last is dot post. Okay, so even if you don't mention these stages here, but if you use standard names for the jobs, okay, stage names for the jobs, GitLab will always run these stages. Okay, so first it will run dot pre jobs, then it will run build jobs, test jobs, deploy jobs, dot post jobs. You don't have to mention these stages block at all, because these are the standard names and this is the standard order. Okay, but if you have other stages like build, test, and then dockerize, something like this, these are non-standard names. So that's the reason why you need to mention the stages order. Okay, and one more thing, what if there is a job, there is some job, and if it doesn't define any stage? Okay, so what will happen in this case is it will automatically assign to the test job. Okay.
Okay.
Now you can see here, this is the pipeline view. So where you'll have the stages and you have the individual jobs. Okay, so the jobs inside each stage will run parallelly. Okay, and let's say that you have hundreds of jobs, but you wanted to currently disable one of the job, just for test. Okay, so you wanted to concentrate on the other jobs, so temporarily wanted to just comment out a job, you don't want it. So there are 2 ways to disable a job. One is you can comment out this whole part. Otherwise, simply if you put a dot at the beginning of the job name, okay, so that will be disabled.
Okay.
Okay, so that is one thing. And also, sometimes we need to make a job as a manual job. Okay, so manual job means, so automatically it will not be triggered in the pipeline, so someone has to go and manually run that. Okay, so this is usually done with when to manual. Okay, so when is just like a conditional statement here. Okay, so it decides how a job should run. Okay, so when you set it to manual, this job will not be executed. Okay, although it will be shown something like this inside your pipeline view. But if you say this job is not executed, if you simply click on this play button, this job will run. Okay.
Okay.
And also this when takes a lot of options. Okay, so the default behavior of all the jobs, as I already said, if any of the job fails, all the other jobs will not be executed. Okay, but
Yeah.
here you have various options. So if I set when to on success, Okay, so then what will happen to that job is it will run only when all the other jobs in the previous all the previous jobs are executed successful. So this is default. So if you don't put any when, which means it will default to on success. On success means only previous jobs when they are successful, then only this particular job will execute. It is any job. Okay, if you set
Okay.
it to manual, this is a manual job. If you to set it to always, which means this job will run irrespective of the build status of other jobs. On failure means that particular job will run if at least one of the job is failed, at least one of the previous job.
Okay.
Okay, and if you put it to delayed, you will be delaying the execution of the job for a specified duration. You can configure it. And if you put it to never, it is just like you are disabling that job.
Okay.
Okay, like that. Okay. Now
Yeah.
let's talk about variables, because variables are very much required, in order to use them across the pipelines in multiple places. Okay. So variables can be defined in multiple places in your, GitLab. Even in case of Jenkins, you can define them basically in the secret section. You can define them in the Jenkins file. Okay, if you see inside the environment variable, we will be able to define, right? These are actually global, but if you define it in a stage, same environment block, then those variables become the local to that particular stage. Correct. In fact, for a folder, you can define environment variable. So in Jenkins also it is there. In GitLab CI also, we can use variables just to avoid hard coding them. Okay, we will use the variables. Okay, so one is predefined CI/CD variables. So what are these? Predefined means these are just like the environment variables. Okay, so in Jenkins, if you remember, okay, in Jenkins you have environment variables, right?
Yeah.
Okay, so how do you access Jenkins environment variables? So after the Jenkins URL, if you simply press envars env-vas.html, I think. Okay, it will
Yes.
define all the environment variables. Of course, you can simply create one stage and you can run simply print env. Then automatically it will print all the environment variables in Jenkins as well. Okay, similarly in GitLab also we have predefined environment variables. Okay, so those will be dynamic, like you can access the current branch name, project ID, job ID, lot of things. Okay, similarly you can set the variables in .gitlab CI YAML file, just like this. Okay, these variables can be global and local, again we will see. So there are project level variables. Okay, so why project level variables we require is, let's say I don't want to define the variables here due to security concerns. Okay, then what I'll do, I'll go to project settings and then there I'll set CICD variables. So those are not visible, but you can access them using dollar the name of the variable. Okay, there are group level variables. What is group level variables? You can create a project. I mean, you can have multiple projects in a group, right? Then if you set it at the group level, all the projects will inherit it. Also, you can pass the variables through APIs. Got it? Okay. See, when we should define the variables in your pipeline file, only when they are non-sensitive, like the URLs, usernames. Okay. Something which is not a secret. If it is a secret or a sensitive value, you should always go to project settings and you need to define them, like your tokens, secrets, credentials, SSH keys. Okay, got it?
Yeah.
And of course, not everyone will be able to access those project variables because they have the secret information. Only the project members with at least maintainer role and above can only add, delete, or access those variables. Okay.
Yeah.
Now, how do I see the list of environment variables in GitLab? Simply create a job, and inside the script, run a print env. That's it. Then automatically it will show you all these environment variables. Of course, you can also go through this link and see it. Okay. So like CI job name. Okay. So this is the job name. So that will be accessible using this name. Like host name, what is your host name of the runner? Okay. GitLab user login, the project name, job status, pipeline ID. Okay. So every pipeline that you run, okay, will have a separate ID generated every time. In fact, every job will have a name and it will also have a ID. Okay, got it? Like repository URL, job stage. Currently, what is the job stage? Let's say I wanted to do something depending upon the job stage. Then I can access the job stage, something like this job stage Then if it is double equal to something like this, then I can do something. So for all the conditional logic also, it is very important, like job URL, build stage. Got it?
Yeah.
Okay. So these are all the list of the predefined environment variables, of course, for a particular project. Okay, you can see the email address, the pipeline ID. Each job will have a different ID every time when it is recreated. There are a lot of things that you can use through configure. And the most common variables that we use is CI commit ref name. Okay. So what is CI commit ref name is? It is the commit branch name. Okay, that triggered the
Okay.
pipeline. Okay, then some in many places you will also see instead of name it is slug. So what is slug is, it is just, it will convert this name into some meaningful format. Okay, so what it will do is, let's say your tag or branch name is just like 100 characters. It is very difficult to use such 100 characters. So what this CI commit ref slug will hold is, it will have the branch name, but it is restricted to 63 bytes, which means it will cut that branch name into and it will cut till the first 63 bytes. Okay.
Okay.
And everything expect the numbers and alphabet. Okay, if you have any special characters in your branch name, it will replace it with hyphen. Got it?
Okay.
And let's say you're cutting till 63 bytes, right? And if the last byte has the hyphen, then now what it will eliminate it. Okay, now see this example 7.3.0-24 plus deb8. So this is just a name for the branch or a tag. Okay, but if you read this name, what it will do is all the dots will be converted into hyphens. Any special characters will be converted into hyphens. Okay, clear?
Yeah.
So this is ideal in case if you wanted to tag a Docker image. Of course, you can use the branch name, but the problem is it might have some special characters. So it is always better to use the ref slug. Okay.
Okay.
And the pipeline source. So what is the pipeline source? This is also important. Let's say you have a job and you wanted to run that job only when the pipeline triggered through a merge request, not for the push event. Okay, then this CI pipeline source will define what is the source, whether it is a push event or it is a schedule event, someone triggered through API, or it is a merge event, it is a pull request, trigger. Okay, it can be anything. So that will hold the actual job trigger.
Okay.
Okay. And now look at the global versus local variables. Okay, so we have stages and we have individual jobs that we already understood. So we have variables here, section here. Then you can define key colon value. Then what will happen is any job can access this. So you have global variables, then you can access them within any job. Okay, so if you move the same block inside a particular job, then those are only accessible within that job. Okay, so these are all very important. Okay, that's the reason why we are discussing before starting the pipeline. Okay.
Okay.
And then you can also mask a variable. So in case if the variable contains a secret information, okay, you can select this mask option when you're creating a variable inside the project settings. Then within your job logs and all these, the value of the variable will not be shown to you. Okay, so for better management of all the secrets, it is always advised to use external secret management tools like HashiCorp Vault. Okay.
Okay.
Then how do you go to how do you set the project level variables is, so once you have a repository, okay, it is actually called as a project in GitLab. Okay, you go to project settings, CICD, and then inside the variable section you can add a name value to that variable, whether it is a simple value or it is a file like variable. Okay, and then you can set whether you want to mask that variable or not, similarly like this. So you'll find this kind of user interface when you go to
Okay.
project settings, CI/CD variables. Okay, if you see, I this is for the previous project. You can see here I have 5 different variables, and all of them are masked. Okay, so some
Okay.
variables cannot be masked. Okay, so like SSH key file, it cannot be masked. Okay, so not all variables can be masked. Now coming to the keywords are also very important. Okay, So we'll understand why. So there are again global level keywords and job level keywords. Okay. So what are these keywords is, okay, the first keyword that we will understand is the default keyword. Okay, so what this default keyword will do is it will set the project defaults. Okay, so let's say that how many times a particular failed job should retry. Okay, so what is the timeout? Okay, and then here you have something known as after script and before script in GitLab. Okay, so you know what is script block, right? It will simply execute whatever are the shell commands that you write. Okay, so similarly, we have something known as before script, and then we have after script. Okay, so what is this is before running the script, whatever you put it inside the before script, that will run. Okay, and
Okay.
after the script is executed, whatever you put it in after script, that will run. So this is just like post build action.
Okay.
Okay, one other difference is, so whatever you put inside script and before script, okay, they both will run in the same shell environment, but after
Okay.
script will run in a different shell environment. So that you need to remember, it doesn't matter for normal jobs. Okay, got it. And
Yeah.
like, what is the cache that should be used, what is the artifact? So these are all the keywords. Okay, even retry, count, timeout. Okay, you can set it at the global level, or you can set it at the which one, job level. Okay, so whatever you set it at the global level, so that becomes a default for all the which one, all the jobs. Okay, now see here, I'm using a default image type. Why this is required? So currently, how GitLab is set up is, every job that you try to execute, it will run inside a Docker image known as Ruby 2.5 tag. Okay, but this Ruby 2.5 may not have all the binaries required for you, right? So inside this container, I cannot do Terraform in it, because Terraform binary is not there inside it. Got it? In this
Yeah.
case, what I have to do, I have to define a particular image. So that image I can write it at the individual job level. Okay,
Okay.
got it?
Yeah.
Understood? But
Okay.
what if I have to use the same image for, let's say, 50 jobs? So instead of going into all the individual jobs and writing the image tag just like this, I'll put it in the default, which means every job will run inside this particular image, that is Maven image. Okay, but let's say I have a job that requires a different image, then you override it.
Okay.
Understood?
Yeah.
Okay. Yeah, and timeout. So timeout can be set it at the global level, or it can be set it at the job level. So if you see there is this build job and I have timeout set to 10 seconds. Okay, so you can use the same thing under the default. You can set it at the timeout here. Then each job timeout will be 10 seconds. Okay, otherwise only this job will have timeout of 10 seconds because it is defined under that particular job. Okay,
Okay.
now if you see this particular job failed due to a timeout error because there is a sleep command of 20 seconds, but the timeout is only 10 seconds. That's pretty obvious, right? And you can define timeouts in in the hour seconds. It is just like writing in a natural language, like 3600 seconds, 60 space minutes, 1 hour, or you can also put 1 hour. Okay, 3 hours, 30 m. So all these are valid.
Okay.
Okay, now coming to allow failure. Okay, so the reason why we are again discussing all these things, because we are going to use them inside our pipeline that we are going to discuss. So what is allow failure equal to true is, see here, if I don't put it, okay, let's say there is this job that is prone to fail. Okay, so if it job 2 fails, what will happen? The other job won't run, right?
Yes.
Okay, so this is the default behavior. But let's say I don't want to block other jobs and this job is expected to fail sometimes. Then if I say allow failure equal to true, then so this job is expected to fail, which means we are allowing it to fail. Okay, so if you
Okay.
set allow equal to fail, other jobs will not be blocked due to this job failure. Other jobs will continue. Okay, if you don't put this, what will happen? If job 1 fails, other jobs, if you see, they don't run. But if you allow failure to true, okay, you can see even if it is failed, okay, you see here allow failure is true for this, allow failure is true for this. but here it is which one?
Job 3.
Job 3. So job
It's
3,
why
it failed because due to some issue it failed. Otherwise, what will happen? It will also run. Okay, if
Yeah.
you have all the statements, properly. Okay, and again, when we already discussed, when manual means it is a manual job and all that we already discussed. So let's go to the next keyword, and needs. So what is this needs is? Okay, so let me show in an example. So what we discussed is all the jobs will run parallel, right? In case of a stage, right?
Yeah. Yeah.
Okay, but you can you can change this behavior using needs. Okay, so needs basically creates dependencies between the jobs. Okay, so what is the meaning of this is, okay, if you see this Linux build, it is belonging to which one? Build. This is also build, which
Will
means these will run parallelly.
coincidentally. Oh,
Okay,
sorry, parallel.
and also there is this test. So there are 3 test jobs. Okay, usually they should run which one?
Parallel.
Parallelly. Okay, but if you put any jobs and that to needs as an empty array, it will start immediately. It won't wait for previous jobs to complete. I mean, previous stages to complete. It will start immediately, even though this is, let's say, second or third stage.
Okay.
Understood? And if you see, this particular Linux test job requires Linux build job, which is this. Okay. So what is the meaning of this is, once this Linux build job is completed, immediately this job will be started.
Okay.
Okay. It won't wait for the other jobs. But if you see deploy to production, you don't have any needs, which means this is, if this is the last stage, this job will only run at the last. It will wait till all the jobs are completed.
Okay.
Okay. Now let's talk about artifact. So what is an artifact basically in JFrog or in any tool? It is basically the output of something, some operation. It can be a
Yeah.
build log, it can be a Docker image, it can be ZAR file, WAR file, exe file, or it can be a binary. Okay, similarly, we have artifacts and cache. Okay, before that, let's understand what is workspace. So as we already discussed, every job by default runs inside this Ruby 2.5 container, right? So within this container, okay, there is a workspace where your whole job will run. Okay, it can be if you have git clone as part of CI pipeline, all the clone contents will be within that job space, and that job space is known as CI project dir. Okay, so what is the exact location is, it will be under builds, your GitHub username or a group name, and then the project name. Okay, if my GitHub username is Vikram and my project is, let's say, demo, so this will be the path within that workspace. I mean, within that environment. Okay.
Okay.
GitLab stores everything. So whatever you clone it and whatever you do it. Okay. Now we'll see there are 2 stages. Okay. So 2 jobs. Okay. Both, basically belong to a different stage.
Stages.
Okay. So here I have executed my program and then I redirected the output to build.log. Okay. And if you try to echo your project DAR location for this particular job, you can see the build, my username of the GitHub, and then the name of the which one? The project. Okay. Name of the project, if you see here.
Project.
Okay.
Okay.
Now what I did is, since this build.log file is in this job, in the next job, which belong to a different stage, I try to cat that build.log. Will it be successful? No. Okay. Because both are different environments. Both run in a different Ruby 2.5 environment. Got it?
Okay.
Clear. There is no common shared workspace here. That's why this particular job will fail. Okay.
Okay.
Now,
So
how do
each
you
stage will have different workspace or how it will.
correct every job?
So,
See,
oh,
it's
every job
every
will
job
have different workspace,
different workspace. Okay,
not
because the
stage.
environment is different for uh, uh, as you can see the build ID. Okay, so it's
Okay.
different. Now,
Okay.
how do you share those data? Okay, so here the data can be a cache data, it can be an artifact. So both actually store files and folders. Okay, they represent files and folders. Okay, so they both are almost the same, but the use cases are different. Okay, so in our case we are talking about artifact, which means this build.log, we take it as an artifact. So how do I share it across other job? Okay, so let's say this jar file is created in build job. I want inside the Dockerized job. Of course, have to Dockerize this to Docker file, right? Through the Docker file. Then I will read this. I will need this jar file. Correct. Then
Yeah.
what I have to do? I have to use artifacts. Okay, so how artifacts usually work is, let's say if this is artifact, it can be anything. Okay, if I use this as an artifact, then what this artifact, GitLab will do is it will take this artifact from this environment and it will upload to your Git server, or it can be S3 bucket. So however how you configure it. But by default, first it will be downloaded into your GitLab server, and this artifact will be provided to the rest of the jobs. Okay.
Okay.
And why it is uploaded back to your server is that artifact you can see and download it
Okay.
separately. Okay, you can make it to public or it can make it to private. Okay, you have an option to download. You also have option to expire that in 1 hour or 1 day. Okay, similarly inside this run job, if you see, I'm trying to echo hello world into build.log file. Now I'm taking this as an artifact. I want this artifact to be available in the next job. That's the reason why. Okay, I've used this artifact. Okay, and now what is this artifact? It is
Builder.
build.log. So path is build.log. Okay, and then I'm saying that artifact should expire in 1 week. Okay, I don't want it to be stored in the server. I want it to expire in 1 week. Not only this, if you have a folder, that folder also can be artifact. So which means I can have list of paths
Okay.
all stored in the artifact. Now that artifact will be automatically downloaded by the other jobs, which means if you simply do cat and then build.log in your current workspace, it will be available. Now your job will be successful. Okay, so you can download whatever artifact that you generated through GitLab UI or through a simple API call also, you can download it. Now if you see, both the pipeline stages are successful. Okay. Now as I already said, so once you have an artifact, so you can actually go to your particular job, okay, inside your pipeline, and then you can download it from here. So it will be downloaded as a zip file. Okay, you can extract it later. So artifacts can be expired. Okay, so let's say I can expire in 1 week. Okay, or else you can disable artifacts. Okay, let's say by default artifacts, once it is generated, so it will be automatically sent to the other jobs, remaining jobs. Okay, let's say a particular job doesn't require that artifact, then you can disable it using dependencies set to empty.
Empty. Okay.
Okay, so what is this needs is for the job dependency. This dependency is for the artifacts dependency. Okay,
Okay.
you can set the artifact expiry in like 42 seconds, 3 minutes 40 seconds, 2 hours 20 minutes. So these are all the types of syntaxes that are supported. You can also set artifacts to be never. By default, GitLab stores all the artifacts if you don't mention the expiry date. So they will store for 30 days. Okay.
Okay.
And also if you have multiple artifacts that you're trying to use. Okay, so instead of only using the paths, okay, so for each artifact you can also give the name. Okay.
Yeah.
And also you can also exclude some data. Let's say I don't want .o files from all the files and folders, from all the files, okay, inside this binaries directory. Then also you can use exclude. Okay, and here for each artifact, if I want, I can simply define a static name, right? Like my artifact, something like this. But here I don't want the name to be static. Okay, I want it to be dynamic. That's the reason why what I did is CA job stage. So what is this stage? that this job belong to. Let's say there is this stage that that I am setting it to test. Then CI job stage becomes test hyphen commit ref name. Okay, let's say the dev branch. Okay, got it.
Yeah.
So this is a unique name that is generated. Let's say I want other dynamic name. Then I can say CI job name. Okay,
Okay.
or else like say CI pipeline ID or pipeline pipeline ID hyphen job ID also I can do. Okay,
Okay.
those are all the things that you can configure. Okay, got it. Now understand what is cache. So cache is also something similar to artifact. So you have some data present in one job, you want the data to be shared to the other job, but here cache is mainly used for files that you download from internet. Okay, the meaning is when we do Terraform init, so we have all the providers and modules downloaded into .terraform, right?
Yeah.
Okay, now this .terraform folder is needed for init, unit for validate, apply, delete. Okay, if you have different jobs for all these operations, of course this .terraform folder I need to share it. Okay,
Right.
but if I share it as an artifact, what is the disadvantage? Again, I'll have to download from I'll have an option to download. Okay, and you know these artifacts are basically cannot be shared across other pipelines and all that. Okay, but what is advantage of using cache is you can reuse this cache for different jobs, different pipelines, which means if one pipeline for the same project, let's say pipeline one that is executed for the first time, it created that cache, then second a pipeline execution can reuse that cache until it is expired. Got it?
Yeah.
Okay, so let's say I have a job. Okay, so let's say I have 5 jobs. Okay, so all these 5 jobs require a cache. Okay, then I can use it. The same cache I can use it for the whole branch as well. Let's say every time when that branch is being executed, the same cache will be used. Okay, so what cache does is it will speed up your build process, because if you do .terraform folder, if you cache this, okay, in one of the job, other jobs can use it, which means only for the first time you the job will execute let's say for 5-10 seconds, because it will download the Terraform providers and modules. But for the rest of the jobs, what will happen? They don't have to download it, right? They will
Right.
execute faster. This is not the only advantage. Next time if you rerun the pipeline, the first job will not download this .terraform, because it is already downloaded and it is cached.
Okay.
So even for this also, next time it won't take any time.
Yeah.
But artifacts are not like the artifact should be generated every time.
Yes.
Got it? And
Yeah.
this cache you can use it across the pipelines, across the jobs, across the branches. Okay, that is the advantage of using cache. Okay, let's say for Node.js, if you download all the npm dependencies, then this node underscore modules folder will be downloaded, right? That also you need to use it as a cache.
Okay.
Got it? That is the advantage. Now cache, once it is downloaded, you can use it across multiple jobs. And uh, cache can be you can define at the job level, or you can define at the global level. Okay, that is also fine. Then again, cache is just like artifact. You'll have to define path and the name. We call it as a key in cache. Okay, so it can be same name, or it can be the environment variable name. Okay, I'll tell you why that is required. Okay, now see, if any particular job doesn't require the cache, okay, so what you need to do, you need to put it as empty cache. Then that cache won't be injected into this particular job. Like for
Okay.
Terraform FNT, it won't require that .terraform folder, right? Because
Yeah.
it will simply see whether you have proper format or not. Okay, now what is the other advantage of cache is you can reuse this cache. Okay, if you simply put a static name, what will happen is this becomes a static cache. Okay. So what is the
Okay.
static cache is this will be cached in the runner. Always remember, cache will be inside your runner. Okay. It won't be downloaded back to the server just like your artifact. Okay. It will be in the runner. Okay. In order to reuse it. Okay. If you put Terraform hyphen cache as a static name for this cache, okay, so this might affect your pipeline. The reason is, let's say you have this .terraform folder which is cached for the first time. So next time, your pipeline will try to reuse the same cache, but this cache may not be proper, or it may not be valid after 50 or 60 executions of your pipeline, right? Which
Yeah.
means this cache has to be limited, or it has to be cleared. Okay, so let's say that I can name this using CI pipeline ID hyphen Terraform cache. Then what is the advantage of this is, so the every time a new ID will be generated, right? So let's say 123 is the first execution ID of the pipeline. Then the naming is like this. So this cache will be valid. I mean, whatever the data that is there in the path, it is now with this name. Okay, for the next execution, this pipeline ID changes, which means the old cache won't be used.
Okay.
Okay, let's say I want to use same cache for my whole branch. Then what I'll do, I'll replace this whole thing with CI commit ref slug. Okay, which means this is the branch name, right? Which means this cache will be used for that branch. So for all the pipelines that got triggered from that branch, that same cache will be used.
Okay.
Okay, let's say you need to enable per job per branching cache. Okay, so what is the meaning of this is, let's say I have this dev branch and I have a job known as the test job. Okay, for the dev branch test job, I want to use the same cache. Then what I will do, I will use the key like this: job name hyphen ref name, because
Okay.
job names are what you will use, right? Like this.
Yes.
So branch is also static, which means the same cache will be used. But if you put it as job ID, again, it will be different, because the job ID will be different for each job execution. Again, that will be different, which means every time new cache your pipeline will use. Okay, let's say for whole stage in a particular branch, I want to use the same cache again and again. Then it is job stage name hyphen commit ref slug.
Okay.
Got it. So that is the advantage of using cache. So artifacts and cache use it to share the data across various jobs, but artifacts are generally used uh, if you want any data to be available after the end of the pipeline, so that you can download. Okay, it can be zar file, war file, or some reports. Okay, even artifacts will be passed across all the jobs, but cache should only be used, okay, in case if you want to speed up the build process, where you will cache a certain data and reuse that cache across multiple jobs in a pipeline. Okay,
Yeah.
now we almost reached to the end. Okay, so by default, we know that Terraform will use local backend, where it will store the state file and the log file locally. Okay, but if you store the state file locally or the log file locally, what will happen? Okay, let's say for the Terraform apply. Okay, so there is this environment that got created. Okay, so now your Terraform apply will run in this execution environment, and then it generates or updates the state file here. For the next time, if you try to run the pipeline, you don't have access to the state file, right? Because this environment got destroyed. Okay, and also your state file is not there in some S3 bucket or some remote backend. In this case, what you have to do, you have to find other way, right? Okay, so GitLab provides HTTP backend. Okay, so this is the remote backend. Okay, so using this, you can version control your state files, encrypt your state file. You can lock your state file and unlock it. We had seen this in the Terraform cloud, right? Inside the
Yeah.
cloud, okay, you can click on that unlock button or lock button. So same thing is there. Okay, so how do you define this HTTP backend for GitLab? We will see in the practicals. And once you define this backend, GitLab backend, to store your state file, Okay, so under your repository, you have this operate. Under operate, you have the Terraform states. You can click this and see your Terraform state file. Okay, and this is how you actually configure the remote state. Okay, if you remember, if you have to use remote state, S3 as a remote state, then we use S3, and then bucket name, DynamoDB table, key, all those things, right? Okay, so here
Yeah.
it is somewhat different. Okay, so you have to define the backend to be HTTP, and you don't have to put any configurations here. But in the Terraform init, once you're doing Terraform init, okay, if you do Terraform init and -h, okay, you will find all the help commands. There will have the backend config also. Okay, so here what is the backend config for GitLab HTTP backend is backend config address. So address is your this address. So this is clearly given in the documentation also. Okay, so it is GitLab URL, your project ID, okay, Terraform state, and whatever is the state name that you wanted to use. Okay, I
Okay.
think this is hard coded. We will see this later.
So this
Okay,
back HTTP is like keyword, right?
backend.
Right.
It is
Okay.
there in the Terraform documentation also. I'll show you. Okay,
Okay.
but
Fine.
here, the address where the state file has to store the lock address, unlock address. Okay, so how to upload the state file to that address, which means you need to have the authentication information, right? Like username and password. Okay,
Yeah.
and retry, unlock method, lock method. So these are all the things that your remote backend should provide to you. Okay,
Okay.
so GitLab is
Like
providing.
DynamoDB is providing, right? How state
Correct.
lock is.
Yeah, how state lock use. So it will use a lock ID as a
Yeah.
unique identifier of type string, right? So
Yeah.
similarly, your backend should provide all this. So GitLab documentation clearly gives you all this information, like how to use
Okay.
the backend and all.
Okay. Fine.
Okay. So that
Yeah.
is integration of GitLab and Terraform. That's the one integration we'll do. We will see. The other integration is with GitLab and Ansible. Okay, of course, you know, the only command that we run is Ansible playbook and then the host file and Ansible playbook file name, right?
Yeah.
But the thing is, all the EC2 instance that we create use only passwordless authentication. Okay, so we know the username, that is EC2-user, but the private key file will be with us, right? Okay, where we should upload this private key file. Again, we'll go to CICD variables under your project settings. Then we will upload our SSH private key. Okay, but here, how do you securely access your private key? That is very important. Okay, so here we will use SSH-agent. Okay, so this is a key manager for SSH. Okay, so what it does is, so it will read your SSH private key file, and then it will put it inside its memory. Okay, so for every SSH operation, it will provide this SSH key file. It won't write it to any disk. Okay, so this is clearly given in this particular documentation. Okay, so what we
Okay.
have to do first, we need to start our SSH agent. Okay, and then we need to load our SSH key file. Okay, before that, we need to change the permission so that only the user, the owner of the file, have access to this SSH private key file. Then we set some permissions to the .ssh folder, and then your Ansible playbook will execute properly. Otherwise, it won't work. And for all the Ansible operations, if you see, I'm using a different container agent, that is Ansible latest. Okay, so inside this only, you also have this SSH-agent binary running. Okay, so you don't have to rely
Okay.
on creating a separate Docker image or finding a new one in Docker. Got it?
Okay.
So this is about the overall information required to get started with our GitLab CI/CD pipeline. Okay, so now we'll talk about how to implement this practically. So now let's talk about how to implement this overall architecture. So I made a small change in this architecture. Okay, that is, we'll also see how to scan our Terraform configurations using, Aqua TFSec. Okay, so this is the new change that we have added. Okay, and now this is the repository that I have. Okay, so this is not yet pushed into GitLab. Okay, I have this README file that has all the links required to create this pipeline. Okay, so if you want to understand, how to enable GitLab remote backend, then you can follow this link. Okay, so they have clearly given all the instructions. Okay, so this is one thing. And the other thing is, if you want to understand the artifacts and cache, you can refer this link, and how to add SSH keys. Okay, so how to generate the SSH key, and basically how to use that SSH key in your GitLab job. That is also available here in this link. And other examples like CI examples, and also I have given so for the reference. Okay, and coming to the Terraform configuration that we have simple AWS instance. Okay, um, AWS underscore resource type, the local name is web. And then if you look at the variables that I have, okay, so I have these variables. Okay, the reason is set to yes east one. The default instance count is 1. Okay, let's start with only one instance. And then AMI, and we have T2 micro, okay, has the instance type. And here within the AWS instance, so we have count. Okay, so that will create the number of instances. var.ami instance type. Okay, some tags. And also I'm using a key. Okay, it's a key pair. Got it?
Yeah.
Okay, and if you look at the key pair resource, so basically what I did is instead of directly, creating that particular SSH key within the pipeline, so I will create it locally, and then I will directly put the public key value here, okay, which we are going to see now. Okay, this is a key pair, and then I'm referring to that key pair. Okay, so that Ansible, when it tries to connect, it will use the private key for this public key, whatever we are injecting into AWS. Okay, and coming to the security group, so basically it has a security group to allow port 22 traffic and port 80 traffic, because we are going to install a web server. That's the reason we have both 22 and 80. Okay, so 22 is for Ansible to SSH into the instances to install or run the playbook, right? And port 80 is required to access the application. And coming to the egress rules, we are actually allowing all. And this is the security group I am actually referring in my instance. Okay, security group equal to, it can allow multiple security group. That's the reason why this is the list. Okay, and for every instance that I create, okay, so basically I want to have the public IP written into a file or redirected into a file. Okay, so we know that using the local exec provisioner, we can actually do that, right? Okay, so so why I have created null resource, and why I did not actually put this provisioner directly here is, okay, see what will happen is this host file, right? It has to be updated every time. Okay, in case if instance is replaced, okay, or for any case. Okay, but the problem with this, if you put provisioner inside this is, sometimes what is happening is the host file is not being updated. Okay, or else what is happening is this host file is being what is happening actually is it will also has the old IP addresses in this case. Okay, so this is the issue I observed. Okay, so because let's say this host file, I'll take it as a cache, let's assume. Okay, so this host file won't be deleted, correct? It will be there. So first time if I run this instance, okay, that IP address will be stored in this. Okay, second time if I increase the variable count to 3 or 4, okay, so what is happening to this block is, it is actually not deleting, okay, because I did not write that logic anyways. Okay, it is not actually deleting that host file. Okay, and then it is updating the host file with the new IP address along with the old IP address that are already there in this host file. Okay, so what I did is I wanted to run this particular provisioner separately. Okay, every time, even though the AWS EC2 instance is not replaced because there are no changes required, this null resource will always run. Okay, so how it will run is, if you see, I have the triggers block. Okay, that will trigger for every timestamp change, which means even if this resource block doesn't change, it will always run this. Your Terraform will always run this block. And also depends on, I use this reference. Got it?
Yeah.
And then it will trigger for every timestamp. Okay, so how many times this particular resource should run is, it should run for how many AWS instances we are trying to create. That's the reason why it is length of AWS instance dot web. Okay, so for simplicity, you can also do so simply. You can put this var dot count also here. Sorry, here in the count. That also is fine. Okay, now in the local exec, what it is trying to do. Okay, since if you have, let's say, 5 different EC2 instances. Okay, so AWS underscore instance dot web will have list of 5 details, right, of all these
Yes.
instances. That's the reason why. Okay, what I'm doing is I'm trying to read that list, okay, for all the public IP addresses, and using element function. Okay, I'm going to iterate over that list and find out only the public IP. Okay, so here we have count.index that starts from 0 and it will end at the maximum value, that is 4. Okay, because sorry, whatever is the instance, if the instance count is 4, count is 4. That means count will go from 0 to 3. Okay, so for all that, okay, the public IP will be echoed into this host file. Got it?
Yeah.
Okay, and also this host file should only create, should only be created whenever we actually apply the changes. Okay, for the destroy changes, what I'm trying to do is I'm trying to delete that host file. Got it?
Yeah.
Okay, so this is one resource. Variables we've already covered, and then provider block. Okay, so here provider is HTTP backend. Okay, so this is the backend, because if you go to this link, okay, so you just have to mention the backend as HTTP, and you don't have to put anything in the configuration. That is one thing. Okay, and the required provider is AWS. Reason, it is coming from var.reason variable. Okay, clear?
Yeah.
Okay, now when we do Terraform init, so we will have to pass this configuration, the exact configuration, whatever we have it here. So this we will try to pass it in the pipeline. Clear? Okay.
Okay.
So these are the things, and then I have this index.html file. It is simple, HTML file, and I have this Ansible playbook. So what it does is, so whatever host file that you pass, it will run it for all the hosts. It will become as true because it has to run yum install httpd, right? And who is the remote user?
Easy.
EC2 user. In case in the variables, if you choose an AMI that is based on Ubuntu, then you need to change that remote user accordingly. Okay. First, what we are doing, we are installing HTTP, we are starting it. Okay. You can also add one more line to enable it to start at the boot time, that you can add. And then using copy module, what we are trying to do, we are trying to copy whatever local index.html file into var www.html folder, because HTTP basically, it will serve the default index.html file from this location. We're actually trying to override it. Got it?
Yeah.
Okay. Now, if the Ansible requires configuration in the form of ansible.cfg, we will try to pass it as an environment variable. Okay. So for example, I have to disable host file checking. Okay. So Ansible disable host file check. There are multiple ways. Okay. So what are the other ways? First thing is, if I have ansible.cfg in the current directory, right? Okay, so I can actually create this ansible.cfg here itself. So let me actually do it, ansible.cfg. Okay, so inside this, under the defaults, okay, so I can set this value. Okay, so if there is any link, okay, so let me take this link reference. Okay, so there are a couple of ways. One is to set it as an environment variable, host key checking as false, or else if you also have ansible.cfg, okay, so you can also put that, but directly we cannot put. Okay, so let me take ansible.cfg example, because I think it is under the default section. We need to put that. Okay. So just one quick example of ansible.cfg should do. Okay, yeah,
Yeah.
under the defaults. Okay,
Yeah.
so under the defaults, we need to host key checking is false. This one we need to put. Okay, clear?
Yeah.
Okay, so this we can put, otherwise through environment variable also we can put. We will put it in the environment variable because we don't have uh, um, many changes. Okay, and also if you look at the known errors in this readme file, if you try to put that ansible.cfg, so actually GitLab is throwing an error. Okay, and it is ignoring that ansible.cfg file. Okay, so for now I don't have any fix for this. I don't know how to fix it. That's why I'm not using that file. Instead I'll rely on using it as an environment variable. Okay.
Yeah.
And the other thing that you need to do is you need to go to your VS Code settings, go to extensions, and then you need to download a plugin known as extension known as GitLab Workflow plugin. Okay, and if it asks you to download YAML plugin and other stuff as a recommendation, okay, through pop-up, you download that as well. Okay, so one important thing, with this GitLab workflow is, see, once you click on this GitLab workflow, okay, so it will ask you to connect to your GitLab. Okay, so for now it is not asking because I already connected. Okay, so you will get an option to connect, then a browser window will open. Then if you enter your GitLab username and credentials, okay, automatically it will sync up all your repositories. You can see all your repositories here itself. Got it?
Okay.
Okay, so that is one thing we need to do. Okay, and once you log into gitlab.com, if you see, I don't have any projects yet. I don't have any groups. Okay, so here if you compare it with GitHub, a project is just like a repository and a group is just like an organization. Okay, a group can have multiple projects. Okay, so for now what we will do is we will try to create a new project once we log in. Okay, and this project name I'm going to say as Terraform GitLab integration. Okay, and then so I'll put it under my uh, group, user. So deployment, there is no deployment target yet. Okay, so no deployment plan, and I'll make it as public. Okay, initialize repository with readme because I don't need it because I already have it locally. Okay, click on create project. Okay, so now what it is asking you to add origin. Okay, so this origin is for the HTTP. Okay, but what we can also do is we can also excuse me, we can also clone it through SSH, right? SSH URL. Okay, so for this what we can do is we can add the SSH key. Okay, so you can directly add the SSH key directly from here. Okay, so this is just to authenticate yourself. Otherwise, you click on your profile, go to your preferences, and then in the SSH keys, you can add your SSH key here. Okay, so anyways, most of the systems will already have one public and private key, right? By the name ID_SA. Okay.
Yeah.
So if you look at your .ssh folder from uh, your home directory, just a sec. Okay, so you will basically have ID_RSA, which is private key for this public key. Otherwise, what you can do is you can simply do SSH keys in. Okay, and the file name as some file name, let's say test, and then you can generate the SSH key directly from here. Okay, if you see, we have test and then test.pub, but if you have to use this test.pub, it should be in your home directory. Okay, or else every time for pulling and pushing you need to use your private key. Okay, because it is not standard ID_RSA, which is there in .ssh folder. Okay, since I already have it, I will go ahead and take my public key. Okay, just take it from here, copy it, and then simply paste it here. Okay, you can set the expiration date, add key. Okay, so your key is added. Now go back to your you can click on this button, go to your okay. So here now if you see, the clone URL is changed into SSH URL. Got it? Pretty easy, right? Okay, so now we will go to our repository. Okay, so we will see the status of the repository first. Okay, as expected, this is not a Git repository. So we'll do Git init. And also remember, I have this git ignore file. Okay, so this is a standard git ignore file. You can also search for git ignore file for Terraform. You'll get this option. Okay. And yeah, so let me. Okay, so this is now a Git repository. Okay, so let's do Git status now. Okay, and then add all the files. Git status are all in the staging. Now git commit to commit into your local repository first. Okay, and then git status. You should get an empty output for now, and then use git. So we need to add the remote, right? So git remote add origin URL. Okay, so we have added it. Okay, so now git push origin. Okay, since we are currently on local master, we'll push them to remote master. Okay, and also if you click on this this GitLab workflow button, okay, you will see this. Okay, got it?
Yeah.
Okay, you can see that. Okay, now that we are pushed, let's refresh this. Okay, so you have all the files. Okay, and here currently auto DevOps is disabled. Okay, so we will enable it automatically. It gets enabled once you push your GitLab CI file. Okay, so now what we will do is we'll try to create our first CI file. Okay, so how do we create? Just create a new file with the name called GitLab-CI dot YML or YAML. It is up to you. Okay, so first let's start and create a base template. Okay, so let's say we have stages. Okay, so see, this auto suggestions comes only if you have GitLab workflow installed and also YAML extension installed. Okay, that's the reason why once I write stages, it is actually giving me these names. Okay, so let's say I have a stage like a build. Okay, another stage, let me put it as something known as test. Okay, and then let's say it is deploy. Okay, so these are the stages that gets executed, and we have a job. So let's say I name a job known as build job. Okay, so inside this build job, what all things we can put? First thing is we need to mention in which to which stage this belongs to. It belongs to build stage. Okay, and then I can simply start to write this script. Okay, script is again it will have list of commands. Let's say echo build. Okay, got it?
Yeah.
Understood? So this is a simple
Okay.
job. Now let me write other couple of jobs. Okay, so here I'll say it is a test job, belong to the test stage, and then I'll say this is echo test. Again, simply deploy job. Okay, the stage belongs to deploy, and then echo, it says deploy. Okay, then what we will do, we'll simply first commit, and I'll also say am, so I don't have to do git add again, and double n git push origin master. Okay, I'll do it in a single command. Okay, so because this is the first time we are actually adding this file, so first time you need to do git add am, sorry, git add -a, and then you can use the above command to push. Okay, so as soon as you push, okay, so there are many things that will happen in the background. Okay, so if you simply refresh this, okay, you will see a dot kind of thing here, which it says it is running. Okay, and if you want to see all the pipelines, okay, you need to go to this build and go to pipelines. Okay, then you can edit your pipelines directly in GitLab using pipeline editor. You can schedule the pipelines and you can access the artifacts, everything from here. Let's go to pipelines. Okay, so this is our first pipeline. Okay, so the pipeline this is the pipeline ID which is running on master. For this commit, it is initiated by this person, and there are 3 stages. You can also see first stage is completed. It is now executing the second stage. Okay, you can cancel your pipeline here, and then you can, if you have any artifacts, you can download it from here. Okay, then if you click on this pipeline, you can see the whole pipeline view or whatever the jobs. Okay, and if you go to the jobs tab, you will see, okay, so build job, test job, and deploy job. Okay, you can also rerun individual jobs by clicking on these buttons. Okay, let's see the build job output. Okay, so let's understand this log. Okay, so it is running inside this runner. Okay,
Yeah.
got it. And then if you see, by default it is using Docker executor, and which is based on Ruby 3.1. Okay, so that is the default container in which all your shell commands will be executed. Okay, and whatever you put it in the script, those will be executed. Because we have put echo build, it shows build. Okay, similarly you can check the logs of the other stages by directly clicking on the stage, and then you can access all the jobs from that stage. By clicking on the job, you will directly be going into the console output of that job. Okay,
Yeah.
understood. And one more thing is, you don't have to go to the UI part to check your pipeline. If you go to GitLab workflow, okay, so for the current branch, okay, I think if you keep refreshing this, right, you can see here, okay, your pipeline, job, and job log. Okay, if you go to deploy job, you can directly see the output here. Okay,
Yeah.
you can access individual jobs directly from here. You don't have to even go to your GitLab.
Console.
Okay, got it.
Yeah. Okay.
Now let's try to actually implement the things. Okay, so build, test, and other jobs, we don't require them. Okay, so we will start with the stages such as okay, I know what is the Terraform workflow. First we need to use Terraform FNT, right? Okay, so what is Terraform FNT stage? Let's say the stage names is format. Okay, you don't have to put it in quotes as well. Okay, so first stage is Terraform FMT. So that's where the stage is, let's say it is format. Now the job name also I'm giving it as format for simplicity. And within this, what we have to write, we need to first write to which stage this one will belong to. This will belong to the format stage. And then I have to run the script, right? Okay, so what is the script? Script is Terraform FMT.
FMT.
Okay, but the problem is this Terraform FMT may not be available within the Ruby 3.1 container. So how do I know? Basically I'll commit this GitLab CI file and push it. And then if you go to GitLab workflow, this is an easier way. You will see one more new pipeline in some time. If you keep refreshing, okay, you will get that directly information. Now let's go to this format job live log. Okay, see, it failed because Terraform command not found. Okay, so where exactly is your Terraform command? It is in your Docker image by the name HashiCorp/Terraform. Okay, so you have other tags, but you can go for latest tag. Okay, so for that, what I can do is I can actually write the image that I wanted to use it here. Okay, so HashiCorp, okay, / Terraform. Okay, I can do this, but the thing is, the same image I would be requiring for the multiple stages, I mean multiple jobs. That's the reason why what I'll do is I'll try to create a default section. Okay, so inside the default section I will again create a default image. Okay, so the default image name should be this. Okay,
Yeah.
then all the stages, until unless they will override at the job level, okay, every job will use this. And also this is the image name, the entry point I will also make it as an empty, because I'll be writing my own commands. Okay, otherwise they will come with their own entry points that might interrupt my actual command and it might fail the content. So I'll override the entry point to make it as an empty. Okay, so this is the default one. And we also have timeouts, retries, right? That we already discussed. So I can also put the timeouts directly at the default section. So every for this complete job, so the timeout can be 15 minutes. Okay, got
Yeah.
it. So you can also have retry count and all put, but it's not required for now. Now this format stage, what it will do is it will actually run inside this Terraform container, and then it will do Terraform FNT. Okay, so let's quickly commit this and see. Okay, so this is format. Then next, what is the other thing that we will use in
Terraform.
Terraform is
Container.
next thing is Terraform, but validate, we know, right? Validate will fail if we don't have the providers downloaded, which means we need to download provider first.
Init, right? Terraform init.
Correct. Okay, so if you see the pipeline now, the stage, see Terraform FNT, it actually executed. Okay, now we will define another stage. So this stage, we call it as an init stage. Okay, inside the init stage, okay, so let's define a job known as probably download provider. Okay, so download
Yeah.
provider, and then this becomes to a stage known as init. Okay, and coming to the script, so what we will do, we'll write Terraform init.
Init.
Okay, that's it. So what Terraform init will do, it will download the provider and all that stuff. Okay,
But we need to pass our requirement, right? The backend
yeah,
we
that we
showed
will
that.
see, that we will see.
Okay. Okay.
Okay, so because Terraform runs all jobs in separate environments, we might lose the state, so we will also go for the remote backend. Okay, so now what we did, so we committed it and then we pushed the change. Now you should, if you go to your pipeline also here, okay, you can see one more pipeline. Okay, it is now running. Okay, it is running format is completed. Now if you see the download provider, okay, again it is also running inside our HashiCorp, which one, Terraform. Okay, so what exactly it is saying, error asking for input to configure backend HTTP. Okay, the reason why it errored out is, so within our repository itself, we mentioned the backend as which one, HTTP. Okay, so that's the reason why it is now asking to provide that. Otherwise, what you need to do is you need to remove this backend block and then commit it, so your pipeline will run. Okay, so we will now try to store this Terraform configuration. Okay, so inside our um, GitLab, okay, Terraform state file. So for this, if you go to this Terraform state file, okay, the first requirement is we already enabled this backend, that is done. The second thing is, um, you know, we need to provide this TF username, TF password, okay, and then TF address. So these are all the variables that we have to, okay, decide. Okay, so let me simply copy this whole data, okay, and paste it somewhere. Okay, so these are all variables, right? Okay, these are all variables. So what I will do is I'll set them as global variables. Okay, so I'll write variables. Okay, so TF username, TF password, um, anyways, I'll directly store it. Okay, username is your GitLab username. This is just your GitLab personal access token. Anyways, that I will first create it. Okay, so what we will do now, we'll go to our GitLab, and this is your project, right? Go to your project settings, go to CICD, and then go to variables. Okay, so here what all variables we'll add? We'll add our GitLab username and GitLab password. Okay, because if you see inside the backend, it is asking for a username and password, TF username and TF password. Okay, so go to variables. Here add a variable. Okay, so the what will be the variable name? Okay, you can use anything, right? Let's say tf underscore username. Okay, so what is my username? You can see in the GitLab URL as well directly. Okay, this is my username. So if you want, you can mask this variable. Otherwise, because this is just a username, you can simply click on add. Okay, so now you can see tf username. Okay, you can also edit it and then mask it later as well. Okay,
Yeah.
now go to another variable. So this I'll also mark it. This one I'll say. So what is the value they're expecting? It is tf password. Of course, you can say GitLab token, whatever name you can use, you can use it. Okay, that's not a problem. Okay, in fact, let me use it like this. So let's say I'll say GitLab token here. Okay, but I don't have the token, right? So let me actually open my profile in a new tab. Okay, let's open GitLab in a new tab. Go to my profile, preferences, and then go to access tokens. Okay, add new token. Token name is uh, let's say Terraform. Set the expiry date and then give API access. Create personal access token. So this is the token. First, let's copy the token. Okay, so here I'll save this as GitLab underscore token and then paste the token. Click on add variable. Okay, similarly, instead of TF username, I will just change it to GitHub username just for simplicity. Okay, so two are done, correct? And yeah, so let's now go to our pipeline. Okay, so what are the other things they are expecting? Okay, so this is the whole init config, right? So backend and this. Okay, so let's actually copy the whole thing here to modify easily. Okay, so Terraform unit backend address. Address is TF address. Okay, what is TF address here? HTTP gitlab.com API v4 projects. Project ID. Of course, project ID means automatically for every project it has to take, right? But what is my project ID? Okay, I don't want to hard code it here. So instead, what I will do, instead of this project ID, so for project, if you remember, we have a lot of CI variables, right? CI uh, project underscore ID. So for every project, it will override.
Yeah.
Okay. Now Terraform state, this is the state name. Okay. For the state name, what I will do is I'll say something like this state file underscore name. Okay. Equal to what should be the state file name? Let's say, let's use the same state file. Okay. Terraform dot tf state. Okay. Now I'll use this name to write it here. So it is again dollar within this parenthesis. I will put it here. Okay, so tf address. Okay, so tf address. So this will be used. Okay, I'll cut it here. I'll cut it here and then I'll paste it here. Okay, I'll paste it here. So one tf address is done, right? But here it should not be equal to and all. It should be colon. Okay. So one TF address I've used here. Okay, next thing is TF username. So what is our TF username now? So TF username is colon. So it is directly coming from GitLab variable. So it is, so we have stored it like this, GitLab underscore, I think user underscore name, right? We have stored it
Yeah.
like that. Okay, and then TF password. Okay, so TF password is again dollar. So it is GitLab token. Okay, this is how we stored. Got it?
Yeah.
Okay, so now let's delete this whole thing. So now if you see, these are the variables. This is the Terraform init configuration. Okay, so TF address we have done. That is address. Lock address is TF address slash lock. Unlock is slash lock again. Username we have set. Password we have set. Wait, post method, everything we have set. Okay, so we need to replace this whole Terraform init now. Okay, so here, got it. Okay, but here this is we don't require this new lines and all. Okay, so indentation is sufficient. Okay, so we have to indent it properly. Okay, so we need to indent it properly like this. And here we can remove all this. These are not required. Okay.
Yeah.
Got it, because we already indented it. Okay, so everything will be taken properly. Okay.
Yeah. Okay.
Okay, username token. Okay, so everything is set. So now what we will do, let's simply add and commit it again. Okay, so let's see the pipeline directly here itself. Okay, anyways, format will run properly. Okay, so next time we will disable format just for time being. Okay, to check other things, you know. Okay, now downloading the provider. Okay, job succeeded. Okay, so now your Terraform log file and the state file should be available if you go to your Terraform repository. Okay, so it should be under operate, under the Terraform states. Okay, you should find your TF state file. Currently, you don't have anything yet. Okay,
Yeah.
got it. Now what we will do is we will go for the other stages. The next stage is validate stage. Okay, validate. This is the stage name. And now I'll simply copy this format and then I'll try to edit it here. Okay, so this is the name itself. I can use job name as validate, stage name is validate, and here we'll also say it is validate. Okay, now here comes the issue. Okay, so first thing is we'll disable this format job. For that, what I have to do, I can comment it out or simply put dot. Okay, so that job will be disabled. So let's commit this file and also push your changes. Okay, and meanwhile let's go to our repository, go to our pipeline. So new pipeline will be triggered. Okay, so you will see one job is missing, that is FMT job, because you disabled it. Okay, so this is your init job. Okay, so init job is successful. Let's go to your pipeline and see the next job. Okay, that is validate job. Okay, so validate job fail because it says missing provider. Okay,
Yeah.
understood.
Yeah. Okay.
Okay, that's the reason why. Okay, we need to pass that whatever .terraform folder that you have from one stage to the other stage. Okay, otherwise your validate stage will fail, saying that your configuration is missing. Okay, so for understanding again Terraform cache, you can refer the README file. Okay, so there is this artifacts link. Okay, so this is for both cache and artifacts. Okay, you can go to probably the jobs. Yeah, cache and artifacts. So cache, how to do, how do you create a caches? You can actually create cache at the job level or at the global level also. Okay, you should have a cache key and whatever files that you wanted to cache. Okay, it can be files or it can be paths. It can be both. And also you can have cache with a name. Okay, so let's simply copy this syntax. So now instead of because this particular .terraform folder is required by multiple jobs. Okay, so what we will do is we'll put the cache directly here. Okay, so cache, and that is the key. We will modify the key. So what will be the paths? The first path will be .terraform. Got it?
Yeah.
Okay, so Terraform slash. So the other thing is, you can also pass, this is not required, just for the example. Okay, so you can also pass the log file for your dependencies. Okay, if it is required. Okay, so these are the two paths. And coming to the name, as I already said, if you give a standard name, Okay, test cache. So what will happen is, this is, since this is just a static name, so this same cache will be reused for multiple pipelines in this particular repository. Okay, so if the cache is very old, what Terraform does is it will try to use that old, old folders only. Okay, so that's the reason why cache should always be used, you know very carefully. Okay, you need to make sure that the cache is cleared regularly, and you are using cache across the branches, or across the pipelines, or across the jobs. And I want this particular cache to be very unique for every pipeline that I write. Okay, that's the reason why what I will do is, I'll simply say CI pipeline ID. Okay, because every pipeline will have a different ID, right? Okay, that's the reason why I'm selecting a cache key, so that that cache key will be unique for each pipeline. Okay, for this pipeline, the same cache will be used for all the jobs. Okay, if you want,
Yeah.
you can tune it with the different other names, but just I'm using pipeline ID and Terraform cache. Okay, and that cache will automatically given to all these jobs. Okay, but if I don't want that cache to be passed to some jobs, let's say for the format job, although it is disabled, once we enable, like, it will run. But for that, I don't require the cache. Okay, got it? Because it's not required. Terraform is not required for the formatting. That's why what I'll do, I'll say empty cache. And also, even if this fmt command fails, I want the other jobs to run, which means I will allow this job to fail. Okay, so how do I allow it to fail? If I set allow failure to true, which means even if this job fails, you know, I want other jobs to continue. Got it?
Yeah.
Now we will commit these changes and then see, what will happen. So, okay. So format done, init done, validate done. Then what we have to do now? So we need to apply the changes, right? So I'll simply say a job called apply configuration. Okay. Apply configuration. Now I want this to a part of stage known as, let's say, probably apply. Okay, so I'll add that stage after this validate. Okay, so meanwhile, let's go and see what is happening to our pipeline. Let's go back to the pipelines. Okay, so our download provider is completed. Let's see now validate job. Okay, you can see our validate job is also successful. It is saving the cache. What exactly it is saving again? Saving cache. It is saving the .terraform folder.
Okay.
Okay, it is being used by this validate. I think if you go to your previous job, that is the init job. Okay, init job means download provider job. A log, so it you will also see it is cached. Okay. By the way, you'll also get the email notifications once your job fails or successful. See, creating cache, you can see this is a pipeline ID and whatever name we have given. And then it is just uploading those two files into cache. And by default, this GitLab shared runner will upload them into some Google storage. Okay. To reuse them for the other jobs. Okay. Now coming to our apply stage configuration. So what we need to do? So we need to write this script. Okay. Inside the script, what will be our first command? Okay. So Terraform apply. Okay. So let's say auto approve also. Okay. But the problem is we need to have the AWS credential set, right? Otherwise, how it will work? It won't work, right? Correct. So for that, let's go to AWS. Go to, sorry, let's log in first. And then go to the IAM service. Users. Okay, so create a new user. We'll call this user as for GitLab. Don't provide management access. Attach policies directly. Okay, give him administrator access. Click on next. create user. Once the user is created, click on the user, go to security credentials, and then create access key and secret access key. Okay, click on command line, accept the confirmation, click on next, create. Okay, so these are the access keys and secret access key. Okay, now let's go to our project, go to project settings. Okay, go to CICD, variables. Okay, so here what variable I'll add is add variable, and then this key is AWS access key ID, so it will automatically populate. Okay,
Yeah.
then go back here, copy your access key first. Okay, you can actually mask it, add variable. So okay, that variable is added. Now add the other one, which is AWS secret access key. Okay, and copy your secret access key and paste it here. Click on add variable. Okay, so now those are also added. Okay, how do we actually use those variables? Okay, so if you go to our Terraform registry, and go to providers, AWS provider, go to documentation. So you can use those credentials multiple ways. Either you can put them in the provider block, which we don't want to expose. Otherwise, what we can do is we can actually export them like this. Okay, got it? So we will export them like this. So we can write those lines here. Okay, so let me modify it a little bit. Okay, so export AWS access key equal to, so we are trying to now read from the read from where? Read from the variables, right?
Yeah.
Okay, anyways, this is the same name which we have used. Okay, and then for the secret access key. Okay,
Yeah.
and you can also move them into before script block also. Okay, if it is required. So now, okay, so this is one thing that we have done. Okay, but the thing is, we did not actually use this key pair. Okay, we did not update it. Okay, so for this, what I will do is I'll create a key known as GitLab. So SSH-keys in, and I'll create a key pair with this name GitLab. Okay, in the same directory. Okay.
Yeah.
So I will take the public key. Okay, I'll just copy the public key, and then for the AWS key pair resource, I will use it. Okay.
Okay.
Public key equal to, so I have to paste this public key here. Okay.
Yeah.
And coming to the private key, so I don't want to use that private key directly. Okay. So if you see in the .git ignore file, I would have actually ignored it. Okay, so I don't want to upload to my, which one? Okay, into my source code. That's why I entered it in the .git ignore file. Okay, and before I can put it locally because it won't be uploaded. So I'll take this content, okay, and then I'll create a variable because I would require it for my Ansible operations. Okay.
Yes.
So I will actually upload it now only, so we can also upload it later, and then we will call it as SSH something like private key, and then just paste the value. Okay, so you can try to mask, but this doesn't support masking, so that's another challenge. So click on add variable. Okay, so that variable is also added. Okay, yeah, so I will use that variable, okay, for my Ansible operations. Okay, that's the other thing. Okay, so now what we did is we are trying to apply the changes, and coming to the values, we'll be basically creating, I can say we will create 3 instances. Okay, instance count is 3. And going to my jobs. Okay. See, format job, I disabled it for now. Validate job also I will disable it. Okay, because I want to speed up this process. Anyways, init I require. Okay, because it will download. After init, basically we will go ahead and apply the changes. Okay, understood?
Yeah.
Now let's commit and see. Okay, so go to our build, go to pipelines. Okay, so while they are executing, so let's also do one more thing. Okay, so once this is done, right? Okay, so basically I will also create a job known as Ansible. Okay, so this is another job by the name Ansible. So this should belong to, let's say, configure stage. Okay, I
Yeah.
will also put that configure stage here. Okay, so for now, I'll simply say script. Okay, something. Okay, because I will write it once we see the previous pipeline output. Okay, and after that we should also have the destroy job, right? So here I'll say it is simply destroy infra. Okay, and this belongs to a stage known as destroy. Okay, so for this access key and secret access key are not required because no, these are required. Okay, uh, yeah. Okay, so destroy. So this also becomes destroy. Okay, so we need to add this change, right? Add this destroy stage here. Okay, got it? And I
Yeah.
don't want to automatically run that job. So for that reason, what I will do is I'll simply say when to manual.
Manual.
Okay. Now let's go back and see the previous pipeline. Okay, it failed. Okay, so let's see why it failed. Apply configuration. Acquiring the state lock. Terraform requires a state lock to protect from being. Please resolve the issue. Okay, it seems there is some issue with the state lock. So why there is some issue with the state lock? So this is the TF address, CI project ID. Okay, so the name is correct, right? CI project, CI underscore project underscore ID, Terraform state. So that is the state file name. Okay, that's the reason. Okay, so where is the state file name here? Correct.
Yeah.
We did not write that state file name only here. Okay, state file name. So which one we have used? I think it is terraform.tf state, I think. Okay. This is one thing. Then, yeah, so this Ansible and all, let me try to disable it for now. Okay. We'll try to create them once we are done with the other changes. Okay, let's commit them again and then push. Okay, so let's wait that till that pipeline completes. Until then, so this destroy infra, we already added that stage. Okay, and then this should actually destroy, which is a manual job. Okay, now coming to the Ansible job. Okay, so what exactly will run in Ansible? We'll run Ansible hyphen playbook, right? Okay,
Yeah.
so Ansible hyphen playbook. Okay, and then the playbook name, whatever we have, install apache.yaml. Okay, so but this requires what we require. We require the host file because we need to put -i and the host file. Okay, but where exactly is the host file? That is one question. The other question is this Ansible needs Ansible binary. Correct. Where
Correct.
exactly this is available? This is available in you know there is an image Docker Hub. I think it is some Alpine Linux or something. Okay, search for Docker Hub for the Ansible. Okay, here this one, Ansible Linux / Ansible. Okay, so this one will have your Ansible - playbook binary, which means this particular Ansible should run in that image this. Okay, so we are
Yeah.
overwriting with this name, and here we should also have the work what do you say, entry point replace. That's why I'm changing it to a name, and then the other thing is entry point should be, you know, it's empty. Okay, like this. Now
Okay.
this will run. Okay, but the problem is here it needs the host file and also our SSH key. Okay, because we have this GitLab private key, right? That we need to use to SSH into the instances, because this GitLab.pub is used as a key pair. Okay, now let's see our pipeline, previous pipeline, what is happening to it. Okay, so here it failed at the init stage itself, download provider itself. Let's see why it failed. Requires auth. Okay, but we have given auth, right? TF password, TF username we have given, right? TF username. Okay, and it's GitLab. Okay, GitLab username and GitLab token. Okay, so let's go and see with what names we have actually used in the settings, CICD, in the variables. Oh, that's the error. Okay, so we said it
GitHub.
is GitHub. It is GitLab. Okay, so again here it's, oh, it is fine, right?
Yeah, that only.
Git, okay, that one. Okay, so now instead of going and going into our repository or VS Code and committing new changes, let's go to the pipelines here and then run this pipeline here itself. So click on run pipeline and click on run pipeline. So this should start a new pipeline automatically.
Okay.
Okay. In the meanwhile, let's try to configure our Ansible. Okay, so inside Ansible, we need to find the host file first. Okay, so we are going to get the host file. If you see our main.tf, okay, so within our work directory, okay, workspace, so we will be having this host file. Okay, so I want this host file to be copied because it is being generated in the previous stage, right? So what is the previous stage? So we have the previous stage in the apply configuration. Okay, so that host file will be created from this. Okay, I want that host file to be available here. Okay, so if I use as cache, it will give me problems. So for that reason, what I'll do, I'll use it as an artifact. Even in fact, artifacts that are created in one stage or one job will be passed on to the other job as well. Got it?
Yeah.
And also I have an option to actually download that the file to see the list of hosts that Ansible manages. Okay, so now going back to our previous job. Okay, so let's refresh and see where exactly we are. So download provider is now completed. Now if you see the Terraform apply, okay, so now if you see it has applied. Okay,
Yeah.
so it has also updated a lot of things. Okay, and then let's go back to our operate and then go to Terraform states. Here we have TF state. So how do we know whether it will automatically use this state file? Is if you go back to reset instances. So first you need to see three instances, right?
Yeah.
Okay, you can see web server 1, 0, and 2. Let's see whether our security groups are used or not. Okay, by going into security, okay, you can see 80 and 22 port,
22.
those are used. And also security group name is whatever we decided. And if you
Okay.
go back to the details, okay, so we have list of IP addresses and all that stuff. And the key pair resource is also whatever we have used. Okay. Now, if you try to rerun this same pipeline, okay, so let's go back to build and pipelines. So it should not actually create other set of things, right? So let's run pipeline again, run pipeline. Okay, so that is how we know that it is actually using the proper state file. Okay. Got it?
Yeah, Vikram.
Okay, so meanwhile, what we will do is, okay, so we'll go to this link which is there in README on how to use the SSH keys. Okay, so first thing what they say is you need to create an SSH key pair, which we already did, and then we need to create a variable. Okay, and then run SSH agent to load that variable. Okay, so how do you run that SSH agent? You need to run this, which means, okay, so before our Ansible playbook binary, so what we need to do is we need to first run this. Okay, and then we need to change the permission and then add the SSH key file. Okay, so if you remember, we have used the same variable name, right? SSH underscore private key in our CICD variables also. Okay, so which means I don't have to do anything here as well. And
Okay.
after that, I need to change the permissions of the folder. Okay, that's it. After that, I can do anything, any SSH operation. Okay, so we'll take this private key file automatically. Okay,
Okay.
and but I'm still missing this host file here, which we will fix it. Okay, let's now go back to our previous pipeline and see what exactly is happening in the apply configuration. Okay, so now apply configuration is faster. Okay, if you see, it is actually replacing these null resources only. Okay,
Yeah.
so which means it is not touching any of the EC2 instances because they are already created. But it with this null resource, we are actually you know updating that file.
Host
Okay,
file.
okay, updating that host file. Other than that, it is not doing anything. If you go back to your instances and refresh, okay, you will still see only 3 of the instances. Okay, now how do I get that SSH key file is, okay, so if you go to the artifacts, job artifacts, okay, it's the same thing. Okay, so you need to use artifacts path, and also artifacts, you can also have expiry date. You can also set artifact name as well. Okay, something like this. Clear?
Yeah.
Okay, so let's copy here because your artifacts will be generated in the apply configuration phase, right? Okay, so let me uh, put it here, artifacts. So what is the artifact? We only have one file, right? That is in the current
Host.
directory, it is host. Okay, I can also set an expiry date if I require. Okay, so expiry, expire in. Okay, so let me do it one day. And the name, artifact name, I want it to be unique. Okay, so I don't want that artifact to be same. Okay, so how do I differentiate? I can simply say, okay, dollar. So for every job I require, right? Okay, so let's
Yes.
say CI job, but CI job name, the name will be same. That is apply configuration for all the runs. Okay, so if you want to create a unique name, you can actually also add another variable which will vary for sure. That is job ID. See, job name might be same, but job ID will be changed every time this same job is rerun. Got it?
Yeah.
Okay, so now we have this artifact, okay, called with this name. It will actually artifact pack this host file, and then that host file will be passed on to the other stages. Okay,
Yeah.
and it will expire in one day. Now let's um, enable this Ansible job as well. And so this Ansible job will now get this artifact automatically pushed into this job, but this doesn't require the .terraform folder, right? Okay, so which means I can disable cache for this job. It's not required. Okay,
Yeah.
got it? And this destroy job also, I will enable it by simply removing the dot at the beginning. Okay, and since this is manual job, I'm completely fine. Okay, so almost our the end-to-end pipeline is ready. Let's save it and let's commit it. Okay. Okay, so anyways, our hosts are already created. EC2 instances are already created. So it should now move quickly to the apply configuration. Okay, so why? Okay, so my pipeline is not started yet. Yeah, so now if you see, there are 4 jobs. Okay. Okay, so what we will, so once this is successful, okay, so anyways, I'm expecting it to be, it to execute without any issues. Okay, so we will also include some security inside this. Okay, so how do you, scan your Terraform configurations is, okay, so we have something known as TFSec. Okay, Terraform Sec from Aqua Security. Okay, so it's a very easy tool. Okay, all you have to do is download the binary. Okay, you can download it in multiple ways. You can use Chocolatey in Windows to download, or you can download the exe file directly from the releases page. You can use this curl to install it on Linux. Okay, or else if you want to do it inside a CI, you can simply use this as a Docker image. And how do you actually run this is, okay, if you go to the top, I think you have to just do TFSec. Okay, so let me go to the, uh, I think examples, not here. They should have it somewhere. Okay, so I'll show that. So basically, once you run that, it will show you all these alerts. Okay, so how many of the issues are critical, how many are normal, all those things. Okay, so this is how you use it. Simply, if you should invoke that binary and put a dot where you have all the configurations, then automatically it will run. Okay, and then it will show all those errors and everything. And of course you can also use ignore rules in case if you want some rule to be ignored. You can also use those ignore rules when you are trying to execute tfsec command. Okay, so that we will see. Let's go back to a pipeline and understand where exactly we are. So it failed at the configure job. So let me see why it failed. Okay, so it failed. Okay, unrecognized option, change mode, SSH private key. Okay, I think we have a different variable. Okay, it could be the reason. Let me go to CICD variable, go to variable, SSH private key, the same thing, right? Okay, SSH private key only, change mode is also that. Okay, Alpine Linux. Okay, so stage is configure. Which image we are using? Alpine Linux / Ansible. Okay, entry point is also set. Okay, script eval change mode is also fine. SSH mkdir change mode, Ansible playbook. Okay, so here I need to add -i host file as well. This is one more thing. Yeah. Okay, so let me commit it and see what will happen. Getting. Let's go to the build again, pipelines. Again it started, so let's go back to the previous error and check one more time. Okay, unrecognized option, change mode.
In CHM mode only it got failed, it seems.
Change mode 400 SSH private key file. Yeah, that's what is expected. SSH add, same SSH private key file. Let's see what will happen. Let's see the Ansible job again. Oh, again it says This unrecognized option hyphen begin. Why? Go to CICD variables, SSH private key, edit it. We have everything correct only. Let me delete. Oh no, let me clear this. Let me take this key again and then put it and then edit variable. It's correct only. Let's go to the pipeline, jobs. Okay, this is failed. Let me try to retry it once.
I think we can use like instead of number, we can use. We suggest to use something like that or read right.
Yeah, but unrecognized option hyphen begin, it says. If you check this, there is no other configuration, either evaluate and then change mode. Okay, what else is the issue here? So you are pasting it correctly only. No problem in that. SSH private key file. Should we use these curly brackets? I think it's not required. Change mode. No, because we need to remove other permissions for others, right? That's why it is 400. Let me push and see it again. What was the error? Unrecognized option, right? So let me search for this. Why exactly? Unrecognized option. Okay, it should be of type file. No? That's the error. Correct.
Okay.
Okay, because this is injected as a file, so it should be a file type. Okay,
Okay.
that is the reason we are missing it. Okay. Now, anyways, it will fail. Okay, so
Yeah.
let me go to our pipelines. Okay, so let's stop this pipeline. Okay, so now it should run. Okay, anyways, after Ansible. Okay, so we will also write this which one. Okay, not
TFSec.
after Ansible. So after validate, right? So after validate, let's say we will write one scan stage. Okay, so this should belong to a stage known as so which one we will say, let's say security. You can scan something like this. Okay, and then let's also write this stage in the proper order. That is, after validate only we will run this. Okay, and then scan. So this will have a separate image, right? So
Yeah.
this image, so let's go to TFSec. Where exactly? This one, the CI one. Okay,
Yeah.
this one, and then see directly I cannot put the entry point. unless I separate them into name and entry point like this. Okay. Otherwise, if you don't want entry point, simply put image colon the name of the image, that will work. Okay. If you need any extra options, then you need to follow this approach. Stage is done, entry point is done, and then what we need to do, we need to do script. Okay, inside the script, it is simply tfsec cf dot. Okay, and also I will say that allow failure to true. Okay, because I still I did not test this, right?
Yeah.
So which means I don't want it to block other stages. Simply let's put it allow failure to true, and then commit all our changes. Okay. Okay, still we did not see the artifacts also. We will see. So once this entire thing is completed. Okay, so first stage it is running is init. Yes. Now security scan. If you see, it failed. Okay, but it did not block the other job because I know it should fail. Okay, and there are a lot of things. Okay, so if you see, these are all the critical issues you need to fix. Okay, so we'll fix them. So first, what it says is ingress rule is allowing public internet. Okay, so in order to fix it, what we will do is we need to restrict the IP address. Okay, so there are other suggestions as well. You can refer to this link. Okay, so this link says instead of doing this, you restrict it to the known IP address from where you can access the instances. Okay, which means I can use my own public IP. Okay, the other thing is also same thing. It is fully open for the IPv6 traffic. Okay, so 4 errors are only because of that. The other
Okay.
error is again that. Okay, again this one. The next thing is it says your instance does not for what is this IMDS is. So this is instance access. What is the meaning of this is I forgot. So instance metadata. Okay. So for that, if someone requires access to the instance metadata, they should also have a security token. So that configuration, we will configure it by looking at this. And after that, it says your root block device is not encrypted. Okay, so how to encrypt also, it is there in this Terraform registry documentation, AWS documentation, or else you can also visit this link, and then you can simply, instead of false, you can simply put it as true. Okay,
Okay.
to pass it. Okay, but we will see that later. First, let's see whether our pipeline is successful or not. Other stages. Again, this configure job, Ansible job failed. Okay, it failed because host key verification failed. Okay, but let's see whether it really got this host file or not. Okay, so where exactly this host file will be generated and given as an artifact inside our apply Terraform apply configuration. Now if you look at the Terraform apply configuration, you have the job artifact. Okay,
Okay.
that artifact is uploaded to GitLab server, but cache is uploaded to some object storages. Okay, you can actually download or browse that host file whatever we have. Okay, and then simply you can download it because you can't directly see it. Okay, so now, so let me open that file. You will see all the IP addresses. Okay,
Okay.
now which means that is working. So where exactly it is failing is it
Host
is failing
file
at
check.
the host key file checking. So, okay, so if you have multiple Ansible jobs, you can put that host key checking false in the global level. Otherwise at the job level also you can put. Okay, so I'm going to use that export command. Okay, export Ansible host key checking is equal to false. So where exactly we will use, we can directly use it at the which one? Where? You can set it at the environment variable here, or else simply in the variables block itself, I can put it, right?
Yeah.
Okay, so how I'll put it? So it is Ansible host key check should be colon. Okay, and then because it won't accept in data types like this, so simply put it as a string. Okay, now
Okay.
Ansible host key checking is set as false. Okay, then rerun it. Okay. Okay, so meanwhile, while it is getting executed again, the pipeline is getting executed again, let's fix this all the TF related issues. Okay, so first issue that it is saying is um, this CIDR block is actually allowing more traffic, that we will fix it later. Then the other thing it is asking is, yeah, so root block device is not encrypted in the AMI instance. Okay, so here they have given the suggestion, or you can go to the Terraform registry. Okay, so this is AWS underscore instance, right? Okay, I can search for root block device. Okay, so this root block device, what I can do is I can basically set the encryption to true. Okay, that's the same thing. If you go back to the Acco security suggestion, they are also saying the same thing. Okay, so which means we need to configure this one here. Okay, so if you configure this in our EC2 instance, it will now trigger a recreation. Correct.
Yes.
Okay, so that's fine. So let it recreate. Okay, so now that should fix it. The other issue it is saying is um, instance doesn't require IMDB access, IMDS. Okay, so that is instance metadata. Okay, if you go to this Terraform TFSec documentation, so it says for accessing the instance metadata, like details of the instance, so session token is required. Now in order to enable it, so we need to use these metadata options. Okay, it will be given in the Terraform documentation as well. Okay, so let's uh, you know do it like this. Okay, now for simplicity, let me also do Terraform FNT locally, so to fix all these indentation issues. Okay, so that should fix couple of issues. Now let's go to our pipeline and see what is happening. Okay,
Right,
so
that
now if
was.
you see, it got passed, and the other job, that is destroy job, got failed, I mean skipped. If you want to run it, you can simply click on this and you can simply play. Okay, so now in the instances Ansible, okay, so it must have installed, you can see it has installed HTTP started, and then it has repeated for all the hosts inside that host file. Okay, so which means if I simply take any of the instance IP address directly from the management console or from here, so I should get that index.html file, because in the security group that port 80 is open, you can see it is accessible. Okay,
Yeah.
so another things that we will also try to fix is, okay, so inside our that scan job, let's also fix the other issues. Okay, so for now our uh, ingress rules allows all the IPv4 traffic and all IPv6 traffic. Okay, so those are the couple of things that we will fix it. And the other one is egress is fine, that is fine. Okay, and the last one it says is it is very low. Egress rule doesn't have any description. Okay, uh, okay, ingress rule has a description. Okay, egress doesn't have it. Okay, so let's write a description. Okay, so description is egress allow. Okay, something like this. Now what I will do is I'll replace all IPv4s. Okay, I mean not all IPv4 egress. it can ignore, but ingress, I will replace it with my own public IPv4, my IP address. Okay, so let me see what's my IP. Okay, so this is my IPv4 also I require. I think first one is better. What's my IP address? Yeah, IPv6 is not detected. Okay, it's okay. So let me copy my IPv4. Okay, and then I will put it here. Got it?
Yeah.
And then coming to the IPv6, since I'm not able to. Let me see my IPv6. I think IPv6 is not detected in my case. Okay, so let me do for sample. Okay, maybe I'm not in the dual stack. Okay, some IPv6 I'm using. Okay, just to avoid that error. Other than that, I don't have any intention to
Okay.
use this. Okay, and now let's go to our GitLab CI file, and let's see. Let's enable all the jobs like validate, FMT, all the jobs now. Okay, so it will be like final test. Let's commit all the changes now. Okay, now go to our pipelines and let's wait for the final. Okay, so now you can see there are a lot of stages. So FMT, init, and then validate. Okay, security scan. Okay, apply, configure, and then destroy. Okay. Okay, it failed at the validate. So why it failed at the validate? Okay, it's not a valid CIDR block. Okay. So what is a valid CIDR block? Probably I'll take this. Okay, so in fact, what I can do is I can also scan them locally, right? Before actually,
Also, we can remove that, right? IPv6.
yeah,
Serial.
IPv6 also we can actually remove it. So meanwhile, let's do Terraform init locally. Okay. And okay, it will ask for all those details. Okay, and one more thing is, so this tfsec is also available as a VS Code extension. Okay, if you go to VS Code and then search for tfsec, okay, you have tfsec here as well.
Okay.
Okay, so how to use this? It will be shown here. Okay, I think you should click on a tf file. Okay, and run the tf scan, which means I can click on this. Okay, button. This icon tfsec and run tfsec here. Okay, tfsec not found. Okay, check the, maybe it needs some configuration or something like that. Okay, that's fine. Again, this failed. While it failed, Okay. So let's do one thing. Anyways, we can give valid, cider. Okay. So we can check it later. But let me actually comment out all those things. Okay. And then commit it again. Okay. In the security groups, what we'll do is we'll simply say 0.0/16. Okay. 0.0/16. Okay.
Above
Now
you
it
put
should.
10.
Okay.
Zero only above first one.
Sorry. Yeah. 0.0. Okay. Now let's, commit them again. So now it is successful if you see. Okay.
Okay.
So I think we did not give the proper range. So it should be a proper CIDR range. We are actually giving the IP address.
IP.
We are not
Yeah.
giving the CIDR range. That's the reason it's failed. Now let's see the security scan. Anyway, security scan, it will report. I think this is, which one is this? Okay, so it is asking you to give a proper IP address. Okay, it says set a more restrictive CIDR range. Okay, so this anyways we can fix it depending upon the requirement, right? We
Yeah.
can't just simply block that for now. That's why we have used allow failure to true. Okay, so this is instance creation. So now instances should be replaced because we have added some configuration changes like IMDS enabling, and then EBS volume encryption. That's the reason why. Okay, so it has to destroy all the 3 instances and 3 null resources. It has to add all the 6. Okay, again, right?
Yeah.
Because we have changed everything. Okay, and again, new um, host file will be created, and then it will be sent to the Ansible for configuring those resources. Okay, so it is done creating, and then it has uploaded the artifacts for the next job. Okay, so now it will run the Ansible configuration. Okay, it says unreachable. Okay, why it is unreachable? Failed to connect to the host via SSH. Okay, so if I go to the list of instances, okay, so one instance IP address is 52.201. So it is a part 52.201.198.37. Okay, so which means everything is proper, but what it is saying is it is unreachable, operation not permitted. Okay, so why operation is not permitted, if you know? Okay, so we actually restricted that security groups, right? Okay,
Yes.
which means instances cannot create, cannot, um, your runner cannot connect to these instances for configuration. So which means, so we need to be very careful. So when we are actually doing these things, right? So which means we will have to override all this. Okay, so we have to allow more perfect IP addresses, which means, okay, so I'm going to uh, replace or revert all these changes. Okay, got it?
Yeah.
And then simply run it again. This time worker or the runner should be able to connect to all these 2 instances to configure it. Okay, so now you can see, so all the operations are successful. Okay, so let me take one IP address and see whether I'm able to access that HTTP server. Now you can see it is successful. Okay, so all
Yeah.
these stages are successful. So what we can do is, so we can fix the issues with the TFSec later. Okay,
Okay.
so now what we can do is, we can destroy all the instances by simply running this manual job. Okay,
Yeah.
now I can go to this destroy infra job. Okay, so you can see all of these instances are destroyed. So if I go to EC2 instances, and if you see there are no instances, which means all the resources are deleted. And if I go back to my pipeline, okay, so the last job should also be marked as successful. Okay,
Okay.
so
Yeah.
only thing is this TFSec will see how to fix those errors, later. It's not required as of now, because anyways we marked that job to allow failures. Got
Yeah.
it? Okay, so this is the overall end-to-end flow. We almost covered everything. Okay, so only thing is it failed at TFSec, but we talked about how to browse in the infrastructure, configure it, and destroy it. Okay.